very quickly what we did on Friday. A graph is discontinuous if you need to pick up your pencil in the process of drawing it. So discontinuous if your pencil gets picked up. It's continuous if you can draw it in one swoop. Zeros. For zeros, we only care about the numerator, right? Like I jokingly said, there could be like an elephant in the denominator. We don't care what's down there. We only care about the numerator. So the numerator is what matters. You figure out when it's 0, and that's where your zeros are. They also correspond to your x-intercepts. So if you wanted to graph your zeros, you could graph them. -6 and -1 would graph like this. Okay. Next. The vertical asymptotes are when we ignore the numerator. We only care about the denominator. So we look for what would make the denominator 0. And sometimes we need a factor, sometimes we don't. It just depends on the problem. The last one we saw were the horizontal asymptotes, and we had 3 rules. Rule number 1, if the degree of the numerator is bigger than the denominator, 2 is bigger than 1, yes? Then there's no horizontal asymptote. If they're the same, 2 over 2, agreed? You take the ratio of the leading coefficients, so 1/5. If the top is smaller than the bottom, top is smaller than the bottom, then we have a horizontal asymptote at 0. So far, so good? Okay. There's only one bonus thing that I need to show you today that we don't already know. And then we're going to be putting it all together and graphing. So we're going to have to find all the things. Sorry, I shouldn't be doing this while I'm also doing notes. Let the record show I'm trying to cut a string off my sleeve. There we go. That's better. Sorry, it was trying to attack me. And it felt like there was a bug on my arm. And I'm like, I can't. Okay, we're all better. All right. So we're going to talk about how to find if there is a hole in your graph. And then we're going to put, like I said, everything together. And we're going to graph and find all the things. Okay? All right, so let's talk about just holes for a minute. Holes, we care about both the top and the bottom. Here we go. So we're going to start by factoring. So look at your numerator. What could I factor that into? X plus 3 and x minus 3. And in the bottom I have x minus 3. Okay. What parentheses are a match in both the top and the bottom? X minus 3. If you ever have a match of parentheses in the top and the bottom, you've encountered a spot where you have a hole in your graph. It's like you're walking down the sidewalk and somebody's doing construction and they have like ripped out part of the sidewalk and there's a hole. And you're like, well, I can't. I can't proceed, right? So that's what we're talking about here, like a literal, like there is something missing, I can no longer go forward. So this graph would have a hole at, and it's what would make it 0. So what would make both these parentheses 0? 3. This one I'm going to show to you on my calculator, and then the rest we'll do on decimals. So let me show you what a hole would look like. So remember, on decimals, on your graphing calculator, all the places, these are not like a high-def TV, right? Like you walk into a nice store to get a TV, and at this point, like I've seen them that they're curved and they're 4D, and I don't even know what the 4th dimension is, but it's something. And so, right, they're all super fancy and awesome. Your calculator is not that. So when I go to hit graph, I'm going to see a graph if the contrast is dark enough. Hold on. Okay, now we can see the graph. Also, hold on, let me fix my window. Oh, this one doesn't have that on it. Okay, just kidding. Hold on, I'm going to fix it myself. Because it didn't want to let me do what I wanted to do. Okay, there we go. Alright, so here comes my graph. Do you see a hole in the graph? No, you're not going to see it. However, if I go to the table, so let me go to my table. Ooh, I'm all the way up in the 20s. If I go to my table, remember we said there should be a hole at +3. If I go to +3, there should be an error message waiting for me. Do you see how it doesn't exist? Because again, it's like you went for a walk and somebody ripped up part of the concrete. Like there is a hole in the sidewalk, I cannot go further. There's a hole in your graph. So when we are graphing, which we're going to do in a minute, the way that I would graph it is I would literally put a hole in my graph where that spot is. So you don't need to graph this one yet. We're going to get into the graphing next. But if there is a hole in your graph, literally you're going to give me like a hole in the graph. That's what it would look like in this instance. Okay, I think I only have, let's see. Okay, oh, we're not graphing yet. Okay, so we just want to find all the asymptotes and zeros. So let's start number 1. We just want to find our vertical asymptote, our horizontal asymptote, if there are any zeros, and then also if there is a hole. So we're going to leave a spot for everything, but we may not fill them all in. So vertical asymptote, horizontal asymptote, zeros, and then a hole. So I'm going to write my laundry list for all of them first. So I'm ready to go. Okay, so I have all my things written down. Let's go through them one at a time. Vertical asymptote, where does it come from? Top or bottom? Bottom. Okay, so I only care about the bottom. What would make it 0? -5. So I have a vertical asymptote at x equals -5. Horizontal asymptote was the list of 3 rules. Is the degree of the numerator bigger than the denominator? Yes. So there is no horizontal asymptote. So again, just because we have this list of things doesn't mean each graph is going to have one. Zeros come from the numerator. And actually, I might highlight a little bit. I took my highlighters away first hour. So I will do this matches up with this, right? And then let's go to zeros next. Steal my highlighter from over there. Zeros come from the numerator. Can I tell easily what the zeros are? No. Let's make 2 sets of parentheses and let's factor. X times x is x squared. What are my magic numbers that multiply to -6 but add or subtract to 1? 2 and 3. So I'm going to go +3. What am I going to do with the 2 though? -2, because 3 minus 2 is 1. 3 times -2 is -6. Okay, so I live here after I factored. All right. So what would make this parenthesis 0 if x were what? -3. So -3 would be one of my zeros. What's my other 0? +2. So my zeros happen when x is -3 or 2. So the corresponding points would be -3, 0, and 2, 0. So when I go to graph in a minute, I could use those values, right, to help me graph. So the zeros give us some information. They give us some literal points on the graph. All right, so the whole is if they have something in common. Do they? No. None. Okay, I'm done with number 1. Let's go to Oh, I think this is supposed to be a 16. Make this into a 16. It was supposed to be a nice number. All right, vertical asymptote first. Vertical asymptote comes from where? The bottom. So let's look at just the bottom. This factors into 2 sets of parentheses. Now that it's a 16, what is it going to factor into? Yeah, x plus 4, x minus 4. So my vertical asymptotes are at, yeah, plus minus 4. So you can write plus minus 4. You could write them separately, right? You could write 4 and then negative 4. All right, horizontal asymptotes are the list of rules. How do the degrees compare, top and bottom? They're the same. What do I do when they're the same? Divide. Okay, so I have a 1 and another 1. What's 1 divided by 1? More 1. So y equals 1. Again, make sure your vertical always has x equal. Make sure your horizontal always has y equal. And honestly, for the zeros, you don't need to write x equals. You could just write what they are. Let's look at the numerator for our zeros. So 2 sets of parentheses. I'm going to factor. X times x is x squared. What multiplies to positive 2 but will subtract to negative 3? Negative 2 and negative 1. So step back and take a look at that. Negative 2 times negative 1, is that 2? Negative 2 plus negative 1 more, is that negative 3? Yeah. So my zeros are what would make it 0. What would make this parenthesis 0? What would make this 0? 1. So I've given you all 3 ways that you could write the zeros. You could write them like this. You could write them as ordered pairs, or you could just write the numbers. I don't care which one you do. You don't need to collect all 3, right? So it's one of these 3 ways. You can write this way, or this way. Doesn't matter. Do I have any matches of parentheses? No. So I have no holes in my graph. Okay. Take a look at number 3. Actually, do number 3 on your own. I'm going to freeze my screen. I'm going to do 3. You're going to do 3, and we're going to meet back up. We've already done 2 together. So let's try this one on our own, and then we'll check back in with each other. Alright, I'm gonna click unfreeze. So only look up when you're ready, okay? Spoiler alert. When you're ready, take a look and see how you did. How'd we do? See some fixes. Hopefully they're nothing too major. We did okay. If you got it wrong, do you see why that part was wrong? Whichever part it might have been.
What is the vertical asymptote?
Because I had to pull out an x. And so if this were 0, it'd 0 everything out. So when there's an x sitting out front by itself, that's how that comes about. All right. Oh, sorry guys. Flip. Sorry people in the video. You didn't even know that was coming, did ya? All right. We're not going to talk a lot about the parent function and how it relates in terms of like transformations in this section. However, I want you to just quickly see what the parent function is. So the parent function would be 1 over x. Remember, our parent function is the most simplistic, toned down version of the function that exists. So that would be 1 over x. So this one, if you look at it, is going to have an asymptote at both axes. Okay? And then there are no zeros because there's a 1 up top. So we would see that it doesn't cross ever the x-axis. All right. Next one. We are going to graph. We're going to state any asymptotes that exist in the domain and range. So do you see how for these we don't have to find zeros and we don't have to find holes, right? So it's going to tell you what you need to look for. So you're going to have to make sure you kind of consult your notes and like, okay, what am I looking for this problem? So read your directions carefully. So today on the homework too, you're going to actually follow the directions. Sound good? All right, here we go. So I need my little friend Desmos to help me. If you aren't already at Desmos, go there. And we're going to start graphing these. So I'm going to do 1 divided by. So to get division, you hit the question mark key. Do you see how there's a slash under it? That's the slash that's getting you division. So hit the question mark key. What do I have in the bottom? What's in the denominator? X plus 2. All right, now, do you see how in this graph we kind of have, we call them arms. Do you see how it has 2 arms to it? So we're going to need to graph a couple points in both arms so that we can get both graphs. All right, I'm going to start with this upper arm, the one that's up and to the right. So I'm going to make a table. And I'll put mine back on the screen in a minute, but I'm off the screen right now. So I'm going to start with this arm of the graph. I'm going to hover over the 1 point it gave me. It gave me a point at 0 and 0.5. I'm going to pick another point. Remember, you can click and kind of drag this, and you can pick other points. So let's see. Can I make it? Oh, I'm going to pick that one. So I'm going to pick negative 1.75 and positive 4. Remember, not all the points are going to be nice, and that's okay. Also, remember, there are infinitely many points. So if you're like, I picked a different point, that's fine. There are infinitely many points to choose from. You can pick a different point. All right, that's going to be my 3rd point. Good? All right, now I'm going to go to the other arm of the graph, and I'm going to find some points over here. Let's see. When is that at negative 4? Ooh, I'm going to use this one. I'm going to get one here. Do you see where it starts to kind of like curve? I'm going to get one of those. Ooh, oh, I just saw 3. Come back. Oh, that's a nice one. Negative 3, negative 1. Bless you. And then I think I'm going to pick negative 6. All right, so I have a lot more points than normal on my scratch paper over here. So let me put mine back on the screen. Here's how mine look. I put them in order. Smallest at the top, or the most negative, to the biggest at the bottom. All right, here we go. And we remember there's kind of a break in here, yeah? So I'm going to graph negative 6, 1, 2, 3, 4, 5, 6, and negative 0.25. So like right there-ish. Negative 3, comma 1, negative 1, 2, 3, negative 1, and then negative 2.5, 1, 2, 3, 4, here-ish. And remember what it looked like on your graph. So I'm going to try to mimic how it looked. Now I'm going to graph the other arm. Negative 1.75 and then up 1, 2, 3, 4. Over 0 and at 0.5. Over 4, 1, 2, 3, 4, and up 0.17. So barely up. Shoop, shoop. All right, let's start with asymptotes. And we can use our rules or we can look at our graph. We've got both. So it's gonna help us in that way that like we can have both at the same time. Asymptotes. Vertical asymptote comes from the denominator. What would make my denominator 0? What would make my denominator 0? Negative 2. So my vertical asymptote is at negative 2. Do you see how my graph truly doesn't touch or cross negative 2? Boop, 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 boop. Okay, so there's my asymptote. And that's going to impact my domain. We'll get there in a minute. Horizontal asymptote. If the degree of my numerator is 0, because there's no variable, and the degree of my denominator is 1, that means the degree of the numerator is smaller. So, yep, so y equals 0. So I have another asymptote here. All right, let's talk about domain. Do you agree that I have graph everywhere except for this one little spot? What's the one spot where there is no graph? Where can I have no graph in terms of x? Negative 2. So I have graph from, bless you, negative infinity to negative 2. Do I actually have any graph at negative 2? No. Remember, in our interval notation, that means a parenthesis. In union with, do you see how it picks back up on the other side of 2? So in union with 2 to positive infinity. So this notation for the domain takes out 2, is basically what it's doing. It's a funny way to basically say everything but 2, right? Because you see how it goes from negative to positive infinity? So my exclusion is at, oh, this should be a negative 2. Hold on. Sorry. That should be a negative 2 as well. Do you see how it goes through negative infinity to positive infinity, but it's excluding your negative 2? Does that make sense? Okay, range is going to be the same thing. We're going to go negative infinity to something in union with something up through positive infinity. What's the spot where I can't include it? 0. So that's what's going to go here and here. How are we doing? Let's do one more graph, and then, like I said, when you get to the homework, just make sure you read the directions carefully, because they're all going to ask for something different. So make sure you read it and do whatever it says. Does it ask for domain and range? Does it ask for asymptotes? What does it ask for? So do actually follow the directions and do whatever it tells you to do. Okay. Next one. All right. Let's graph first. I'm going to get my table set up because I know I have a lot of points on my table. We're going to get arms again. All right. This one, I have 1 over x. So I'm going to just edit the equation I already have. So I'm going to go down to the denominator, and I'm going to delete that plus 2. Do you see how I'm just at 1 over x now? If you arrow to the right, it'll get it to kind of pop back up. So it's right alongside, and then I'm going to put my plus 4. Good? Do we have a similar looking graph? Okay. So let's look at our graphs again. Oh, is it -4?
No, it's -81.
Hold on. Oh, no, let's make it positive. I want it to be positive. Make it positive in your notes. Sorry, thank you. I'm not ready for a reflection quite yet. We'll get there. I don't want to do it today, though. Okay, find some points. And again, your choice. I'm going to find 3 points, though, for each arm. So let's see. I'm going to pick you. You are one of the chosen ones. I'm going to pick you. You see how I'm just scrolling around trying to find stuff that's not super awful? And I'm still on that right arm. So now I'm going to go to the other arm and find some. And again, I don't care where you pick yours. Okay, I'll show you the points I picked. Not sure if you picked the same or different. And again, we did change that to a positive because I'm not ready for reflections quite yet. We'll get into those, but we're not there today. All right, I'm going to graph. I have a point at -6. 1, 2, 3, 4, 5, 6. And up at 1, 2, 3.883. -1, 2, 3, 4. Up 1, 2, 3, 7, 5. And then -0.25, comma 0. I'm going to find that there's an asymptote that lives at 0. Do you agree? Because of the x in the denominator? Okay. 0.5 up 1, 2, 3. 6. Over 2 up 4.5. 1, 2, 3. Okay. All right, so for this one, my horizontal asymptote normally lives for this situation at 0, right? So ignore this part for a minute. If you had 1 over x, it lives at 0, yes? Okay. But if I shift my graph up 4, now where does my horizontal asymptote live? 4. And if you look at your points, does your graph ever touch or cross 4? No. So again, now we have kind of 2 ways to like vet and make sure we are in the right spot with our asymptotes. We have the actual picture, and then we're using the algebra too. Okay, so my horizontal asymptote lives at 4. We just said that. Where did my vertical asymptote live? 0. Okay, so this was vertical, and this was horizontal. All right, domain and range are going to be the same as what we had last time. So we're going to have this U in the middle. I don't think I talked about that much. U is for union. That's when you want both of these combined. So your domain is going to touch everything. Negative infinity to positive infinity. Except for what? So domains left to right. What can't I cross? 0. Same thing for range. Oops, I wrote an 8. Surprised I haven't done that more often this year. Okay, negative infinity to positive infinity for range. What's off limits for range? 4. Okay? So your homework tonight is going to be more of these. Read your directions and do whatever it tells you to do. If it says to just graph, then just graph. If it says to find domain and range and graph, then do those things. So do whatever the directions say. Remember last time I changed the directions for you? Today I'm not. I'm saying read the directions and do exactly what it tells you to do. So we are on assignment number 8. We have page 483, numbers 1, 11 to 14, and 17. I would recommend grabbing a sheet of graph paper. There are, I can't remember if there are 6 grids, 9 grids, I don't know. There's a certain number of grids on it. You should only need 1 sheet of graph paper for today. And if you want to put all your answers on there, like I said, that should fit everything you need. Yeah, we should be good. So 1 sheet of graph paper should do it.